Dear friends, I myself, Dr. Bharat Parab, discussing the topic what is a mathematical proof covered in Appendix 1. Now, to start with, let us see some examples. Let us study some examples as first one, the product of two even numbers is even. For example, 12 into 24 is 288, 78 into 98 is 7644, 324 into 2426 is 786,024, etc. And second example, sum of the interior angles of a triangle is 180. These are some triangles drawn. These are the angles, and measure sum of all, that is addition of all these is 180. Okay. Now check this comment. You must have checked the validity of both these statements, this and this. Okay. But this is not sufficient to believe that the statements are true. Okay. As we are not sure that this, that means this statement and this statement taken separately, this statement is true for all the cases, this and this. Okay. See, true for all the cases. We do not know. We are not sure. Okay. If anyone tries to prove by actually multiplying several numbers, we are talking about this now. Okay. If you actually try to multiply even numbers and check, okay, then one may have to keep the process of multiplication throughout his life. Okay. Because there are crores and crores of numbers. Okay. Or we need some foolproof argument that any statement is true, so that we don't have to do like this. Okay. Then we need the process of establishing the mathematical proof. Okay. I am emphasizing on this word process. Okay. We need the process of establishing. Okay. And we are now going to discuss this process. Okay. Now see here, there are two ways. Statement cannot be proved by verifying some cases. So if you try this, then this is not sufficient. Some cases are not sufficient. Use another way. So another approach is proving a statement. This gives rise to a definition of mathematical proof. So here we are trying to see what is the definition of mathematical proof. A process which can establish the truth of a mathematical statement based purely on logical arguments. Okay, on logical arguments. Remember this word. Okay, it's called a mathematical proof. Now here is a statement. Just go through this. Let us see the validity of a statement, that the statement is the sum of any two odd natural numbers is odd. Okay, sum of any two natural numbers is odd. Then if we see that 9 plus 5, these are two natural numbers, both are odd, but the sum is even. So this is not true. Okay, so this example proves that the above given statement is false. Okay, it is enough to find a single example to prove that a mathematical statement is false. Okay, there may be many, but which we find is single example. This example which we are interested in, this is called as counter example. So such type of example is called as counter example. Okay, hence we need to proceed in a right direction to prove a statement. Here are the list of basic ingredients in a proof. Okay, so from the last slide I am repeating these two lines. Hence, we need to proceed in a right direction to prove a statement. Here are the list of basic ingredients in a proof. Okay, so you will see here, first one, to prove a theorem, we should have a rough idea as how to proceed. That is sure. Okay, now look at this example. The sum of the interior angles of a triangle is 180. Okay, then step 1, we are concerned with the property of triangle. Here we will proceed by drawing a triangle. Okay, because we are concerned about the angles of the triangle. Okay, so we should have a rough idea as how to proceed. Okay, so this is the first step. So any triangle, not necessarily a right angle triangle or isosceles triangle, because statement has not specified anything of this. Okay, so this is a triangle and these are three angles marked in red. Okay, so this is the first step. Second one, the information already given to us in a theorem, that is hypothesis, has to be clearly understood and used. Okay, should have complete idea what information is given and how it has to be used. Okay, so we are making a statement and making a practical use of this statement. Okay, in this proof. Okay, so this is a triangle carried forward from the last slide. These are three angles and look at this line. Okay, so step 2, the information is about the angles. Okay, we was talking about the sum of the angles, so information is about the angles. So we need to think of involving angles of a triangle in a proof. Okay, because concerned with angles, so we need to involve them. Okay, we here take the help of construction of this line, that is a important tool in geometry. Okay, now what we are constructing is draw a line parallel to one side passing through the vertex. That means, see, this is a line, this is parallel to this line and passing through this vertex. Okay, see that this is parallel to this and we have constructed it like that. Okay, third one, read this and try to understand this very carefully. A proof is made up of a successive sequence of mathematical statements. One statement, then another statement, then another statement, like that, a successive sequence. Okay. Now see here, we just don't write any statement like that. Each statement in a proof is logically deduced from a previous statement in the proof. Okay, logically deduced, or from theorem proved earlier. Okay, or an axiom or our hypothesis. Okay, now consider this triangle ABC. Okay, step 3 and 4, consider triangle ABC in the above figure. Okay, we have to prove that, that is TPT. Okay, we will write in short henceforth that angle ABC, that is this one, plus BAC, that is this one. Okay, plus ACB, that is this one. Okay, so addition of all these angles is 180. Okay, so that is what you have to prove. Okay, now proof. Now see, we have drawn this parallel to this. DE is parallel to BC. Okay, now if these two lines are parallel, then AB is transversal to these two lines and AC is also transversal to these two lines. Okay, so AB and AC are transversals for DE and BC, which are parallel lines. Okay, so we are taking advantage of a proof proved earlier. Okay, if transversals intersect two parallel lines, then alternate angles are equal. We have proved this. Okay, so alternate angles are equal, and we are taking advantage of this. Okay, so what are the alternate angles? See here. Here DAB, red one, is alternate to ABC. Okay, and as we have proved earlier, these are alternate angles and therefore are equal. So concentrate on red angles. Okay. Similarly, for these two angles, EAC and ACB. Okay, these are alternate and hence are equal. Okay. Now, interesting point. So therefore, angle ABC, ABC. Okay, this red one plus BAC, BAC. This one. Okay, plus ACB, ACB. So is taking this, and this is equal to. Now this is equal to this, so is equal to DAB, DAB plus this is common one BAC, BAC plus CAE. Okay, but we know DAB plus BAC plus CAB. This is unity. The addition of all this because the straight line. Okay, the straight line is unity. Therefore, and these two are equal. Therefore, if this is equal to this, that means angle ABC plus BAC plus ACB is 180. Okay, that is what we have to prove, and we have proved it. Okay, so this is how we have to tackle. Fourth one, the conclusion of a sequence of mathematically true statements laid out in a logically correct order. See, we are talking about the order. Okay, should be what we wanted to prove. The order should be correct. That is what this means. Okay, and that is what theorem claims. Okay, cannot take anyhow like that. Now step 5. Can I refer the previous slide? We have done this there. Angle ABC plus BAC plus ACB. These are the sum of the angles of the triangle, which are given equal as a DAB plus, you can recall this in the previous slide, plus BAC plus CAE. Okay. Now we have used Euclid's axiom. We will just see which one was that. Okay. Here we are using Euclid's axiom, which states that if equals are added to equals, then the wholes are equal. Okay. So we cannot just write this like that because we have to have some proof, some axiom or some previously proved theorem. Okay. In this case, we are using Euclid's axiom. That is, the sum of the interior angles of the triangles are equal to the sum of the angles of a straight line. Okay, got it? Angles of Sum of the angles of straight line are equal to the sum of the angles of triangle. Okay, step 6. DAB, recall that triangle figure. Okay, so angle DAB plus angle BAC plus CAE is equal to 180 because it's a straight line. Okay, here we use a linear pair axiom which states that the angles on a straight line add up to 180. Okay, so we have not just written it like that, we have solid proof or an axiom for this. Okay, step 7. Angle ABC plus BAC plus ACB, okay, is equal to angle CT0. Okay, DAB plus BAC plus CAE is equal to 180. Here Euclid's axiom has been used, which states that things which are equal to same thing are equal to each other. You can refer that. We have written this statement on the basis of this Euclid's axiom. Okay, things which are equal to the same thing are equal to each other. Just think over it, you will get it. Okay, so this is how a theorem is proved by using logical statements. Okay, axioms and previously proved theorems used in succession, that is proper succession. Okay, and yet another example where we are going to use all these steps. So go through this theorem. A product of two even natural numbers is even. Okay, it's talking about product of two even natural numbers. Remember this statement. Okay, now first one, to prove a statement we should have a rough idea as how to proceed. Okay, so step one, let us think about considering two even natural numbers, because we have to proceed and we should have some idea. So we are dealing with even natural numbers, so we will consider two even natural numbers. Okay, the proof, let x and y be two even natural numbers. See, this is how we have proceeded. Okay, so to prove that xy is even, second step, this is just a first step of proceeding, how to proceed. Okay, second, the information already given to us in a theorem, that is hypothesis, this one, okay, has to be clearly understood and used. Okay, so you have to read this very carefully always and try to understand this very carefully. Okay, so step 2 will be all even numbers are multiples of 2. So we are talking about even numbers and you can take advantage of this, that all even numbers are multiples of 2. Okay, then what we are doing, since x and y are even, then they are divisible by 2. Okay, see what we are doing, and can be expressed in the form x equal to 2m for some unnatural number m and y equal to 2n for some unnatural number n. So we are doing all this for our convenience. Okay, we will see in further part of this. Okay, the third one, okay, a proof is made up of a successive sequence of mathematical statements. Okay, there is, these are the statements and they are in succession. Okay, each statement in a proof is logically deduced from previous statement in a proof, or from a theorem proved earlier, or an axiom or our hypothesis. Okay, so we are now studying how the statements are used to prove some theorem. Okay, and the steps involved in proving a theorem, that is what we are studying. Okay, so in this step 3, let us use the logical deduction in a successive sequence as x equal to 2m for some natural number m and y equal to 2n for some unnatural number n, as we have taken. Okay, we have taken this. Okay, we have seen this earlier. Then xy, x into y equal to 2m into 2n, that is equal to 4m into n. Okay, now see the argument here. Since 4 is divisible by 2, xy is divisible by 2. Therefore, xy is even. Okay, so see how logical argument is done. Okay, so fourth one, the conclusion of a sequence of mathematically true statements laid out in a logically correct order should be what we wanted to prove. That is what theorem claims. Told you earlier that this is talking about the order of the statement. Okay, the whole statement says that we have to place the statements in proper order. Okay, so step 4, expressing x and y in proper form as x equal to 2m and y equal to 2m, so that claim can be deduced in proper logically correct manner to prove what theorem claims. Okay, so this is how we have to proceed to prove a theorem. Okay, for example, or third theorem, the product of, she is talking about the product, okay, of any three consecutive even natural numbers. They are even numbers, they are natural numbers, and consecutive even natural numbers. Okay, so every word is important. Okay, the product of any three consecutive even natural numbers is divisible by 16. Okay, now we will see how to deal with this. First one, to prove a theorem, we should have a rough idea as how to proceed. Okay, for this, step 1, let us think of three consecutive even numbers. Okay, even natural numbers, of course, and proceed. So we are going to take multiples of 2. Even numbers means, okay, multiples of 2, so that the numbers can be even without doubt. Okay, now proof. Consider any three even consecutive numbers, and that will be in the form 2n, 2n plus 2, and 2n plus 4. Okay, for some unnatural number n. Okay, these, all these numbers, for any value of n, they will be all even, and they will be consecutive even numbers. Okay, and we have to prove that CGTPT 2n into 2n plus 2, that is the second number, and third number into 2n plus 4 is divisible by 16. Okay, very nice theorem and very nice explanation. We'll see this. The information already given to us in a theorem, it is here, that is hypothesis, has to be clearly understood and used. Okay, step 2, this was a step 1. Step 2, if a number is divisible by 16, means it should be multiple of 16, or the product. Okay, so we proceed as we have just seen. We should know how to proceed, and we are proceeding it here. 2n into 2n plus 2, that is second even number, into 2n plus 4. So all these are consecutive even numbers. Okay, that is equal to 2n into, in this 2 common, 2 into n plus 1, and again 2 common from this, 2 into n plus 2. So this will be the final product, that is equal to 8n into n plus 1 into n plus 2. So remember, it contains n, contains n plus 1, contains n plus 2. Okay, so we will proceed. So next step, let's see, third one, explanation for this step. A proof is made up of a successive sequence of mathematical statements. Each statement in a proof is logically deduced from a previous statement in a proof, or from a theorem proved earlier, or an axiom, or our hypothesis. We have seen this previously. Okay, so we know the statements, that is logically deduced. Okay, so step 3, depending on this, we have to consider that value of n can be odd or even, as we have taken it arbitrarily. So now we have two cases as n is even or odd. Okay, so we'll take one by one. First one, suppose n is even. Okay, then we can write n equal to 2m for some unnatural number m. Okay, we have seen this, we have done this earlier. Okay, logical statement to express n. Okay, because if n is even, then we can take it like this. Okay, multiple of 2, then 2n into 2n plus 2 into 2n plus 4. This is from the previous slide, which is equal to, we have seen this, equal to 8n into n plus 1 into n plus 2. Okay, is equal to, see, we are replacing n by 2m, so it will be 16m into 2m plus 1 into 2m plus 2. Okay, so this is divisible by 16. Got it? Now let us see when n is odd. Okay, so I told you earlier to concentrate on this, that this product contains n, n plus 1 and n plus 2. Okay, when n was even, then we took advantage of this. Now we will see when n is odd, this will get a weightage. Okay, so we proceed. Second case, to suppose n is odd, then n plus 1 is even. Naturally, n is odd, then we add 1 to it to be even. Then we can write n plus 1 equal to 2r in multiple of 2 for some natural value r. Very simple. Okay, we have seen this earlier. Then if this is n plus 1 here, n plus 1 is equal to 2r, then n equal to, n goes here, 2r minus 1. Okay, so with this value of n, we can proceed as this was from the last slide. I'm just repeating it. Okay, 2n into 2n plus 2 into 2n plus 4, that will be equal to, we have taken these two common in both the brackets, 2n into 2 into n plus 1 into 2 into n plus 2, and we were here, this is equal to 8 into n plus 1 into n plus 2. Now we will substitute value of n from here, and you get 8 into 2r minus 1, that is this value in this bracket, will be 2r minus 1 plus 1 and 2r minus 1 plus 2. So after solving this, we get 8 into 2r minus 1 into 2r, this cancels, into 2r plus 1. Okay, so if you take it here, then it will be 16 into 2r minus 1 into r into 2r plus 1. Okay, so the product has 16 in this. Okay, this is multiplied by 16. So therefore 2n into 2n plus 2 into 2n plus 4 is divisible by 16. Okay, so in both the cases, we have shown that the product of any three consecutive even natural numbers is divisible by 16, which both the cases where n is odd and n is even. Okay, so last step, the conclusion of a sequence of mathematically true statements laid out in a logically correct order should be what we wanted to prove. That is what theorem claims. Okay, that means we must have logical statements and they are supposed to be in the proper order. Okay, that is what it means. We have discussed this earlier. The step 4, as the product is multiple of 16 in both the cases, we can claim without any doubt that number is divisible by 16. So this proves the theorem. Okay, this is a great Indian mathematician, Srinivas Ramanujan. Okay, so just read this. At age 15, Srinivas Ramanujan obtained a mathematics book containing thousands of theorems, which he verified and from which he developed his own ideas. In 1903, he briefly attended the University of Madras. In 1914, he went to England to study at Trinity College, Cambridge, with British mathematician G.S. Hardy. Okay, so also great mathematician. Okay, mathematicians all over the world are trying to prove, or rather disprove, Ramanujan's theorem. Okay, so they are very much interested in disproving his theorems. Okay, this is Dr. Bharat Parab helping you in your studies. If you have any difficulty in this topic of mathematical proof, this is given in Appendix 1. So let me know through comment section and I shall solve it. Thank you. Good luck.